Bismillah, Assalamualaikum warahmatullahi wabarakatuh. This is Statics Tutorial Chapter 2. We will be dealing with position vector, unit vector and force vector. This is continuation of the previous chapters, previous tutorials. In the previous tutorials, we have already covered vector in 2D as well as in 3D. For 3D vector, we have already covered how to get the Cartesian vector form if you have the coordinate direction angle or if you have the projected angle, right? So we have two types of angles that we have covered how to get or how to use to get the Cartesian vector form, and today we will be dealing with a different type of information that we can or should be able to use as well to get the Cartesian vector form of the force, right? So it is basically if you only have the coordinate, right? So that is for today. As usual, we will cover the previous exam questions related to the topic. So the PDF is available in the description box below. You can download it and see which question that you want to focus on, and you can see the timeline where each question is being covered, right? So if you wish to jump straight away to any particular question, feel free to do so. You should be able to find in the timeline of the video, inshallah, right? As well as usual, do look into the comment section if anyone pointed out any mistakes or whatever, right? So with that said, let's go for the first question. Okay, in the first question here you can see the diagram where the structure there, and then we are dealing with the force acting on the structure at point A, and it is directed towards point B, right? So with the given information, we have to be able to express the force with the given magnitude of 3350 Newton, if you see the question, how to express that in Cartesian vector form, right? So what is the important information? So this is the skills that you have to be able to apply, right? You have to isolate the relevant or important information that you need to use from other information that you don't need to care that much about for that particular question, right? So in this case, what is critical is the force is just relating from point A to point B, right? So that's the 2 points that we care about, right? So so the coordinate of point A is 0, 10, 15, right? 0, 10, 15, correct? And for point B, it is 5, 17.5, is it? 0, 17.50. Okay, so from these two coordinates, we can find what is the RAB vector, right? This is position vector. You should already learn in the tutorial how to calculate this. Basically, this minus that one, right? So you should get 5i plus 7.5 j minus 15k, right? So the magnitude RAB, so please make sure you write properly to differentiate between vector and magnitude. So the magnitude is just square root of 5 square plus 7.5 square plus 15 square root everything. You will get 17.5, right? So all of these are in meter actually, right? This is in meter, this is in meter. So unit vector AB is just RAB vector divided by RAB magnitude. That will be 5 divided by 17.5, you get 2/7i, and then plus 3/7j minus 6/7k. Now if it is possible, I always prefer to have in fraction because it have still zero error, right? If you have in decimal point, you already round up certain number, then you will already introduce certain level of error, right? So if it's possible, I always stick with fraction until when we need to multiply or whatever, right? So then you have FAB, right, the force itself. So it gives you the magnitude, which is 350 Newton. So multiply by those whole thing, 2 over 7I plus 3 over 7J minus 6 over 7K. Then you will get the answer, right? So multiply this, you get 100I plus 150J minus 300K Newton. So that is the answer, right? So this is a typical calculation that you have to be able to calculate with minimum time, actually, right? Just identify the 2 points relevant to what you want to calculate, and then calculate the position vector, the magnitude, the unit vector, and then the force vector, right? So normally in the final exam, you have this to be the first step on a longer calculation, and sometimes each question have multiple forces, right? So you have to use this for multiple times. Just repeat the steps for each forces sometimes, right? So do not make mistake, because if you make mistake here, it will affect a long calculation after that when we deal with later chapter, right? So make sure you really understand how to get this using coordinate and position vector, right? So that is the first question. Let's move on to question number 2. Moving on to question number 2, right? In this structure, we have a structure as shown there, where it is supported by 2 cables, and we have a force 400 Newton directed downwards, as you can see there. So the question have 3 parts. Express the force in cable AB as a Cartesian vector form. Express the force in cable AC as a Cartesian vector, as well as consider the tension in cable AB from A to B. Determine the coordinate direction angles of the force, right? So there are 3 parts, but we will try to answer one by one, inshallah, right? So for the first part, we need to consider the cable AB, right? We haven't gone yet into the chapter where we replace cables and supports with forces, right? This will be the later chapter, but hopefully you can still imagine what's going on for each cable. For instance, cable AB and also cable AC, each of that is actually exerting a force on the structure at point A, right? So we are considering that force there. So considering force from A to B, we need to express as a Cartesian vector notation, right? So the 2 points that we need to consider is just point A and point B, right? And the force is basically FAB, right? Different than the previous example where the force we know the value. In this case, the force we do not know the value. We have an unknown FAB, right? But we should be able to express it anyway, right, in terms of FAB. So as usual, what is the position vector? RAB. Okay, before that we need the coordinate, right? So coordinate of A is 600 and coordinate of B is 0 minus 3 2, right? Hopefully you can determine from the diagram there. 0, -3 on the other side, and 2 upwards, right? So from here, RAB is coordinate B minus coordinate A, so minus 6I plus 3J plus 2K. So minus 6 minus 3 plus 2. So RAB, what we do to get the magnitude is just square root of basically 6 square plus 3 square plus 2 square. You should be able to get 7. Right, hopefully you can see the blue color, right? I'll change into red perhaps. So from here we can calculate what is the unit vector UAB. Okay, this is much better, right? So it's just RAB, the vector, divide by RAB, the magnitude. We will get all of this divided by 7, right? So minus 6 over 7I minus 3 over 7J plus 2 over 7K. And to get the vector of the force is just FAB is just FAB magnitude times the unit vector of AB, right? So if you multiply this unknown with all of this, you'll just get minus 6 over 7 FABI minus 3 over 7 FABJ plus 2 over 7 FABK, right? So this will be the force AB in Cartesian vector form, right? So that is the answer for part A. Right, before going to part B, I think I want to just straightway go to part C first, right? Because part C is also about the cable AB, right? So I think we just continue on from there, right? So this is part A. Hopefully you understand. This is the force in Cartesian vector form. Yes, in the later chapter, you will deal with this kind of vector a lot, where we have unknown, right? In chapter 2, normally the value is given so that you can calculate to get a value straight away, right? But in later chapter, sometimes we have to do this with this is unknown, and then we have to calculate what is FAB later on, right? So part C, we have to consider the same cable A to B, determine the coordinate direction angle of the force, right? So what is the coordinate direction angle of this force, right? So what is coordinate direction angle? Hopefully you still remember that is alpha, beta and gamma. So if you okay ya, jangan main kisah. Okay. So if you can still remember, like for example, cos alpha is for any vector, that is the vector E divided by the magnitude of that vector, right? Sorry, AX, and then for beta AY, for gamma AZ, right? So any vector in this line divided by any magnitude of that vector, right? So here we can have F, but we cannot use F because F vector, even though we have F vector here, is in the unknown, and the magnitude we don't even know. So we have to use, for example, this one, right? So if you use cos alpha is RABX over, sorry, this is no longer in the vector form, right? It's a magnitude. Yeah. Over RAB, meaning this divided by this, right? So basically, you can relate to this one as well, right? So you will notice that RABX over RAB is this portion, RABY over RB is this portion, RABZ over RAB is this portion, right? So essentially what this means is this one should equal to cos alpha, this one equal to cos beta, this one equal to cos gamma, right? Okay. Kaya. So hopefully you can still follow despite all the disturbance caused by the little baby. Alright, so now how to get alpha, beta and gamma. So if you already have the unit vector, then we can straightly calculate alpha, beta and gamma there, right? That will give you the coordinate direction angle. So alpha will be cos -1, and then here, minus 6 over 7. Minus 6 over 7. Make sure the negative sign is included, right? Because it will give you the different quadrant if you use positive or negative. So if it's negative, the negative should be there. So alpha will be 149 degrees, right? Because it is negative, it is more than 90 degrees. And then beta is cos -1 minus 3 over 7. So it will become 115.4 degrees, right? And and gamma is cos -1 2 over 7, which is 73.4, right? So all of those are the answer for part C. So if you have the PDF, this is part A until here. This is actually part C, continuation using what we have already calculated here, right? So now we go to part B, where we'll deal with the force in cable AC based on that diagram, right? Now consider the cable AC there. Express it in Cartesian vector form, right? So the two coordinate that we need to consider is A and C. So this will be FAC, right? So coordinate A is 600. And coordinate of C is 002. Right, 600 and 002. Right. So then RAC, the process is the same as part A, it's just the different values. So RAC from A to C, so C minus A, so minus 6I plus 0J plus 2K. RAC the magnitude. Okay ya, nak main tu? So square root of 6 square plus 0 square plus 2 square, you'll get something like, if you calculate 6.3246, 6.3246. So unit vector of AC is basically, of course, RAC vector divided by RAC magnitude. So this whole thing divided by this one, you will get something of decimal point numbers. So negative 0.9487 I plus 0J, and then plus 0.31 plus 0.3162K. Right. Okay, and then FAC is just the magnitude, which is FAC magnitude multiplied by unit vector of AC. Right. So just multiply, so we'll get minus 0.9487 FACI plus 0J plus 0.3162 FACK, right? And whatever unit that is, Newton for example, right? So that will be the force FAC in Cartesian vector form. Now one way to check, right? For example, when you get to a certain calculation, sometimes it's worth to spend 1 minute to just check whether you have made any mistake or not. For example, unit vector. How can you check? How can you check whether this is correct? Of course, you can go through back, but one indicator is the unit vector, the magnitude is 1, right? So if you do square root of this square plus this square should equal to 1. If it's not 1, then something is wrong, right? And because in the some student in the exam actually have some value here that is more than 1 point something, 2 point something, you should be able to tell from there straight away that some mistake have happened, right? Because unit vector, the unit is 1, so each component here should be 0 point something. It cannot be more than 1, because if any of this is more than 1, when you you got the magnitude is more than 1, of course, when you square it, right? All right, so that's question number 2. We'll move on to question number 3. So this is question number 3. We have 2 parts here. So we have the structure there where some forces in each cable, and we have the part A and B. Question part A, express the force Fe as a Cartesian vector form, and then part B, determine the magnitude and coordinate direction angles of the resultant forces of the 2 forces acting on the sign at point A, right? So now in part A is straightforward, getting one of the force as a Cartesian vector. We have done that in the previous example as well. But part B is basically involving finding the resultant force of two forces, right? And of course, before we can calculate the resultant force, we have to calculate or determine the Cartesian vector of each forces first, right? So we'll do one by one. So part A first, right? So we focus on Fe there, the 350 Newton, and yeah, so the 2 points that concern us is point A and E, right? Point D and E. Point D and E, right? Point D and E. So the coordinate D is 300 and point E is 004, right? 300,004. All right, so RDE is E minus D. Of course, the value is given, right? Fe is 350 Newton. So RDE is coordinate E minus coordinate D, so minus 3I plus 0J plus 4K meter, right? And RDE is basically square root of 3 square plus 0 square plus 4 square equal to 5, right? 345. And then UDE is basically just RDE's vector divided by RDE magnitude. So all of this divided by 5, you get minus 3 over 5 I plus 0 J plus 4 over 5 K. That's the unit vector. Now what is the force? So FDE vector, or FE, the original question give, is just 350 multiplied by unit vector of DE, which is this one, right? So if you multiply this 350 multiplied by all of this, what you will get is you have negative 210I plus 0J plus 280 plus 280K Newton. So that is FDE as Cartesian vector, and that is the answer for part A, right? So this is the same as what we have done in the previous example, so it should be straightforward. So we will do part B, right? So in part B we have to calculate this step, but there's additional step where we have to find the resultant force. All right, so we have two forces, FC and FD basically. FB and FC, from A to B and also from A to C. So we have to do one by one first, right? So express each forces in Cartesian vector form first, right? So this is an example, a short example actually, where what we have learned at the very beginning actually is the foundation or the starting point of a longer calculation, right? Of course, this is still chapter 2. When we go to chapter 3, 4, 5, the calculation will be much longer. So the first few steps is crucial and critical. So from point A to point B, right? This is for FB there. So point A is 700. Point B is 034, right? 700,034, right? So RAB vector is B minus A, so minus 7I plus 3J plus 4K. RAB magnitude, so I think you know what to do. So when you square root of 7 square plus 3 square plus 4 square, you will get a number of 8.602. 8.602. So UAB is just this divided by this, so you'll get of course decimal point number as well. So UAD will get 0.8138, 0.8138I Oops. Okay, what was it? Plus 0.43488 plus, sorry, this is negative, right? The negative here, so this will be positive. 0.3488 J plus 0.465 plus 465 K, right? So of course the force is 400 Newton, that is given, 400 Newton. So FAB is just 400 Newton times UAB, right? So if you multiply 400 with all of this, you'll get the vector, which is minus 325.5 minus 325.5 I plus 139.5 J plus 186 K, right? So there you go for AB. Now you just have to repeat the process for AC, right? So if you have point A to point C, A and C, so A is 700 and point C is 0 minus 3 4, right? The number is quite similar, it's just that this is negative, so this will be negative, this will be negative, etc., right? So you have to do the full calculation, but I'm just skipping steps right now just to show what will happen if you continue on all of these steps. You'll get FAC will be because this will be the same, this will be the same, this will be different, right? Right, so minus 325.5 I minus 139.5 J plus 186 K, right? You cannot do this in the exam, you have to show the full steps, but I'm just showing the because it will be similar except for the middle there for J, right? Yeah, so I don't think I need to show everything because I think you understand what's going on, right? So from here to here is just the same steps, and then what will happen is, what is FR, right? What is the resultant? Resultant is simply just this plus this, right? So FAB vector plus FAC vector, right? So we just add the X component, Y component and Z component and we'll get the vector. So if you add, you will get minus 651 I, and then this minus plus this, you add, right? So this is the negative, this one cancel each other, so 0J and then plus 372 K Newton, right? This is all in Newton, right? So all of this is Newton, right? Newton and Newton. But of course the question is not yet over because the question asks what is the magnitude and coordinate direction angle of the resultant. This is the resultant in Cartesian vector form, right? So you need to find the magnitude. So how to get the magnitude? So you square root of 651 square plus 372 square, right? Actually plus 0 square, meaning if you want to write in full, right? This square plus this square plus this square. So in terms of the magnitude, when you calculate, you will get 749.8 Newton. What about the coordinate direction angle, alpha, beta and gamma? So if you still remember from the previous question, alpha is cos -1 ax over a, right, for any given vector. So the x component divided by the magnitude itself, right? So what we have here, we have the vector, meaning the x, y, z component, and also the magnitude. So you can use this one, right? So I will use a different color, maybe this one. So for alpha, cos -1 X component will be this one, minus 651 divided by this one, 749.8. So it will be 150.3 degrees. And then for beta, cos -1, so we get the X component, so it's 0 by 749.8. And then what do you get? It should be 90 degrees, right? 90 degrees cos 90 degrees is 0. So gamma, we have cos -1, so you insert Z component, which is 372 divided by 749.8, and then you will get the value of 60.3 degrees. So that will be the answer. Is it clear or is it glaring? Oh, it's glaring, is it? Hopefully you can catch the number. This is 150.3, this is 90 degrees, this is 60.3 degrees, right? Yeah, so that's basically the method. I think hopefully you understand the method. If you just use the correct method, you should get the correct answer, inshallah. Right, so that is I think the third question and the final question for this part, where we deal with coordinate, position vector, unit vector, and force vector, right? Meaning that if you remember from the very beginning, we have learned how to get force in Cartesian vector form by using the projection angle as well as the coordinate direction angle, alpha, beta, and gamma. Now we have the third way, which is using coordinate, right? Just when you have two coordinate, you can find the position vector, unit vector, as well as the force vector, right? And then of course all the process which is addition of vector, etc., for the resultant force, right? So that one we have already learned before, right? So hopefully you understand everything, and this is crucial for the chapters to come after, right? When we deal with various type of operation with regard to vectors, this is the fundamental, how to use coordinate, right? Whatever structure it is, because if you look at the picture, right, originally, right, you have cables, we have everything. Just as long as you get the two coordinates, that is what we need to just calculate this, inshallah. Alright, so hopefully everything is understood. Any question, please do ask. Hopefully this has been beneficial. We end it here, inshallah. Subhanakallahumma bihamdik, ashhadu an la ilaha illa anta, astaghfiruka wa atubu ilaik. Wassalamualaikum warahmatullahi wabarakatuh.